Okay, this video is about how to find area of a triangle inside of the coordinate plane. So we're going to start with a basic right triangle. On a right triangle, the height and base are actually located on the triangle itself. So in this problem, the height is located here. Okay, that's going to be our height. And our base location is located here. Now, we actually do not have to do any form of counting or any form of Pythagorean theorem on this problem. If we're going to calculate the area formula for a triangle is 1/2 base times height. So in this problem, we're just going to count the squares to calculate the length of our base and to calculate the length of the height. When you're counting the squares, do not count this square. That's technically not a side of the triangle. So we'll start with our base. Our base is 1, 2, 3, 4, 5 units long. Base, 5. The height is 1, 2, 3, 4, 5 units long as well. So all we're doing here is we're counting. We counted 5 units for height, and we counted 5 units for our base. From here, we can just go ahead and type it straight into our calculator. Make sure that when you do type it into your calculator that you're putting the 1/2 in parentheses times 5 times 5. We get 12.5. You can leave that as a decimal or press math, enter, and change it to a fraction. Both of those answers would be okay. I'm going to just leave it as 12.5. So our area for our triangle is 12.5 units squared. So this is as basic as it can be because we can count the base and we can count the height. So that is as easy as this type of triangle can get. Okay. To calculate the perimeter of the triangle, we're going to have to do Pythagorean theorem. So we do have a right triangle here. You can build another one off of your picture if you want. So this length would be 5 and this would be 5 because our goal here, if we're finding perimeter, is to calculate how long this side is, which you cannot count. So we're going to go ahead and do 5 squared plus 5 squared equals c squared. 25 plus 25 is c squared. And we end up with the value of the square root of 50 for this length. When we're doing perimeter, we add all of the sides together. Square root 50 plus 5 plus 5. So all I'm doing here is I'm adding the 5 for my height, I'm adding the 5 for the base, and I'm also adding the square root of 50, which is what we calculated here for the length of AB. I'm going to simplify this by 5 plus 5 being 10 plus the square root of 50 units. We do not square perimeter because we're just adding everything together, so there's no need to square it. Moving on, down here, this is an acute triangle. In an acute triangle, the height is located inside of the triangle, so the height is located here. Our base is located here. The base and height are always perpendicular to each other. So again, using our same formula from up above, 1/2 base times height, we're going to go ahead and simplify 1/2, count the base, 1, 2, 3, 4, 5, 6, 7, 8, 9. So our base is 9. Our height is 1, 2, 3, 4. So again, our base length is 9. That's what we counted. Our height length is 4. So what we're going to do from here is type it straight into our calculator. I'm going to go ahead and put the 1/2 in parentheses. 1/2 times 9 times 4 is 18. So my area is 18 units squared. Perimeter is a little bit more tricky. It actually takes just slightly longer because in order to calculate the perimeter of this triangle, in order to calculate the perimeter of the triangle, we already have one side is 9. So we know we're going to have the 9. That's our base. But now we actually need to calculate 2 Pythagorean theorems. I need to know the length of AB. So let's start there first. I'm going to build the right triangle off of it. This is 2 units by 4 units. So 2 squared plus 4 squared equals c squared. 4 plus 16 is c squared. and I end up with 20, so the square root of 20 is C. So this length is the square root of 20. And we did all of that work here. So I'm going to write plus square root 20. I have one more additional side that I need to find the length of, which is side AC. So again, I'm going to go ahead and do Pythagorean theorem on it. Counting the squares, I get 1, 2, 3, 4 as my height. And notice how the height doesn't change as you go around. It should be the same on all these triangles. Then I'm going to count here, 1, 2, 3, 4, 5, 6, 7. Notice again, the whole base was 9. 2 plus 7 is 9. So if you're not ending up with the same numbers, you're actually miscounting your boxes. Okay, so now let's do Pythagorean theorem. We get 4 squared plus 7 squared equals C squared. 16 plus 49 is C squared. 16 plus 49 is 65, and we're going to square root that. So that means this length is the square root of 65. So what we've done here, we now have all 3 sides of the triangle. Notice how in this kind of problem, we're not incorporating the height because the height is actually not a side of the triangle. So we cannot calculate height in here with our perimeter. We need the side lengths. We cannot combine these square roots, so that's pretty much as simple as this gets. So I'm just going to put the word units after it. So notice the difference between this problem and this one up above. On the first one, we just had to do one Pythagorean theorem. We already had our height and base on it, and height was actually included in perimeter because it was a side of the triangle. Now on this problem, the height is interior, and it's not a side of the triangle, so we do not include it when we do perimeter. The last type of problem that you're going to be able to or be asked to find height for and base and area is a triangle that looks like this. Now this again is a right triangle. It's just turned a little bit different, and this is as hard as these problems get because you can't count anything. Nothing in this problem is countable. So again, we are going to still find area, 1/2 base times height, but now in this problem, our height is located here. And that's not a countable distance. So you actually need to do Pythagorean theorem here. So 1, 2, 3, and 2. So to calculate your height, you have to do Pythagorean theorem. You cannot count this diagonal distance. So I'm going to do 2 squared plus 3 squared equals C squared. 4 plus 9 equals C squared. I get 13 squared. I'm going to square root both sides, and that is non-simplifiable. That's not a word. Unsimplified? I don't know. It can't be simplified. So this height distance is actually going to be the square root of 13. I, again, cannot simplify that. I'm going to leave it. So I'm going to leave that as the square root of 13. Now I need to calculate my base. And again, I cannot count my base. This is diagonal. So I'm going to again just count 1, 2, 1, 2, 3. Notice how I get the same numbers. I get a 3 and 2, 3 and 2. If I do Pythagorean theorem again, the math isn't going to change. My answer is still just going to be the square root of 13 because these two values are the same. Don't waste your time doing Pythagorean theorem again when it's just going to be the square root of 13. Now there's a couple different ways that you can type this into your calculator. To do it by hand, I'll show you the easiest way. When you have two numbers that are the same underneath your square root, you can multiply them. So this now becomes 1/2 times the square root. And what you're going to do in your calculator is just do 13 times 13 to get 169. The square root of 169 just ends up back at 13. So half of 13 is 6.5. So 6.5 units squared. Another way to do this is when you have two values that are the same, the square root of 13 times the square root of 13, that's the same as saying the square root of 13 squared. We know that square roots and squareds cancel, so it would just be 13, which is what we got here. So there's a couple ways to do those. You can type it straight into your calculator if you want. it would simplify it for you. Just be mindful, if you are, make sure you put the 1/2 in parentheses. Then you're going to do times the square root of 13. Make sure you close it, times another square root of 13. And again, 6.5. So there's multiple ways to do this kind of problem. Your choice. Let's go ahead and do perimeter now. So for perimeter, we need to find the length of BC. So I'm going to do another Pythagorean theorem. Before we start, though, I know that my base and height are parts of my triangle, so I'm going to have the square root of 13 plus the square root of 13 already part of my perimeter. One of the square root of 13s was my base. One of the square root of 13s was height. From here, I'm going to calculate. I'm going to go ahead and draw my right triangle. So this is a 1 by 1, 2, 3, 4, 5. A 1 by 5. 1 squared plus 5 squared equals c squared. 1 plus 25 is c squared, and I'm going to end up with the square root of 26. So I'm going to go ahead and add the square root of 26 into my perimeter. To finish perimeter here, if you have two that are the same, it's like combining x's. X plus x is 2x. So the square root of 13 plus the square root of 13 is just 2 square roots of 13 plus the square root of 26 units. So we actually just simplified our answer here by doing square root of 13 plus square root of 13. Again, when you are finding the area and perimeter of a right triangle, the height and base are part of the perimeter because they're sides of the triangle.